Oh, Mars is kind of like Earth, right? That's why we daydream about living there. Could we actually move there and make it our new home? And how would we even pull that off? It feels like everyone's chatting about this, but do we have the tech too? Build a Mars settlement? I'm Alex McColgan, and you're watching Astra. Let's think about what it would take to create a human colony on Mars today. I'm teaming up with Rafa from our Spanish channel. If you speak Spanish, go check out his channel. The link is in the description. As you probably know, we've sent robots to Mars like those cool Curiosity and Opportunity rovers. The stuff they found got everyone excited about what's next for Mars now. There's so much interest in Mars that companies like the Mars Society and Mars One are trying to make colonizing to reality. It makes sense because Mars is kind of similar to Earth. Plus, it's the closest place where there might have been life. People have thought this since the 1800s, when astronomers looked at Mars' surface and thought Martians must have built it back then. It wasn't that crazy of an idea considering what we knew. A New York Times article from 1911 even talked about it. Lately, more folks think there could be life on Mars. Even NASA thinks there's something to find. The Perseverance rover, launching this summer, is mainly looking for proof of life. This is a big deal because, aside from the Viking program in the 70s, most missions didn't look for actual life. They were just checking if Mars could have been livable in the past. Basically, they wanted to find old oceans, not tiny bugs. All these missions are setting the stage for what's next. Space agencies and companies want to build colonies on Mars. But how would colonists get there and not die? The trip to Mars takes about 3 months, if you launch at the right time. That doesn't sound too bad. It's like a long cruise. But you'd be in space, outside Earth's magnetic field. It's for at least 3 months. That means you'd get hit with solar wind and cosmic radiation. Being exposed to that stuff for long could give astronauts cancer or even Alzheimer's before they land. Luckily, people have some ideas on how to deal with this. Astronauts could hide behind stuff with a lot of hydrogen in it when constructing the ships. They could surround the cabin with a water tank in the walls, since water has lots of hydrogen. Another idea is to make a magnetic field around the ship, but that would take a massive reactor that fits on the ship, and we don't have that tech yet safely. Also, the farther you go from Earth, the longer it takes for messages to travel back and forth. Don't think twice about calling someone on the other side of the world and only having a tiny time delay at those distances. Light is fast, but in space, distances can be huge, and light is pretty slow. On Mars, it takes 3 to 22 minutes for a signal to reach Earth. That's just one way. So it takes at least 6 minutes for a message to go and come back. Phone calls would be tough, texts, audio, and video would work. But Martian settlers would need to make quick decisions on their own, especially if something goes wrong with gear. But what if we can solve these problems and colonists make it to Mars? Where would they even live? Right now, there's no perfect spot. The North Pole is a possibility because there's water ice there. The Korolev crater, which is 81 kilometers wide, is another option because it's full of water ice. Mars' atmosphere isn't thick enough for water to stay liquid. But you can find pockets of ice at the bottom off craters where it's cold. You might also be able to settle near underground water under the surface. Studies of Mars orbiters have found and mapped out places with underground water all over the planet. It's harder to get than surface ice, but it could mean colonies could be closer to the equator, where it's warmer and solar panels would work better for powering things. Mission planners would want to find somewhere in the northern hemisphere. That's because the ground there is lower. So the atmosphere is thicker, which helps spacecraft slow down when landing. Another thing to think about when picking a spot is whether there are lava tubes. Nearby, a lava tube is a long cave that used to have lava flowing through it. We see these on Earth and on Mars. They could be big enough to build houses inside. While we've spotted lava tubes and caves on Mars, the best places will also have low ground and access to water. Once we pick a spot, missions can start getting the area ready for humans. You can't fit everything colonists need on one trip, so we'll need to send missions ahead of time to set things up. There have been competitions to find the best designs for habitats that can last a long time, but there's no winner yet. People have suggested making habitats out of ice or habitats made from mushroom-like stuff. But most ideas involve using the dirt on Mars, called regolith, to 3D print a habitat using robots. These robots don't exist yet, so we'd have to make them first. Basically, the idea is to dig up dirt, process it, and mix it with water ice to make something like concrete. Then, robots would 3D print the structure layer by layer. Robots and AI be super helpful in getting the habitat ready for the colonists. Building everything by hand would be impossible because astronauts would need to wear suits, making hard work difficult. Once the 3D printed habitat is done, it needs to be strong enough to hold more dirt. These habitats need to protect people from radiation. So the last step is to cover the habitat with even more dirt. That's because Mars doesn't have a magnetic field like Earth, so radiation is a problem on the surface. The more stuff between the sun and the colonists, the better they'll be protected. Once the habitats are ready, colonists can start arriving even with robots. They'll still have a lot to do. Connect power, set up gear, get the site up and running. While they're doing this, they'll probably live in temporary spots, like their ship or inflatable habitats. These wouldn't be very big and would only have the basics. When the real habitats are ready, they'll need to be pressurized. One way to make breathable air is to get oxygen through something called electrolysis and then mix it with nitrogen. Electrolysis also makes hydrogen, which can be turned into hydrazine for fuel. Once you have it, the pressurized air can be kept clean with air recycling systems, similar to what the International Space Station uses. Another way to get oxygen is from the carbon dioxide in the air. That's why the Perseverance rover has a MOXIE module, so we can see if this is possible. But all of this takes a lot of power. Solar panels are an option. But on Mars, solar panels only make about 40% of what they would on Earth, because it's farther from the sun and gets less light. Plus, they only work half the time because of day and night, and sandstorms can mess them up, which has happened before, so it's not reliable enough for a colony. Another idea is to send a cold nuclear reactor that hasn't been invented yet. It would give a steadier power source. The best bet is probably a mix of both, with batteries to store power in case things go wrong. Settlers also need to make and clean water for drinking and other stuff. Ideally, I'll want about 5 liters per person per day. That shouldn't be too hard because we know where to find water on Mars, in the form of ice. They should also use water recycling systems to waste as little water as possible. The International Space Station already does this. Making water is as easy as digging up ice. We could make a place where people can live, an enclosed, safe space with oxygen and water. Then colonists can grow plants for food. But it needs to be treated to grow stuff. The regolith has perchlorate, which are bad for you in large doses, so you need to wash them out with water first. After that, you treat the regolith with fertilizers and mix it with organic stuff to make it good for seeds to grow. One study says it should be possible to grow plants on Mars and the Moon. There's another route to take, which is called aquaponics, or growing plants in water in a closed system. Inside that system, there's a fish pond that adds nitrates to the water with fish poop. Tilapias are common fish. For these systems, because they'll eat anything and can live in dirty water, you can also eat them. It might be better to use both aquaponics and regolith. These farms would use a lot of power and would need colonists to take care of them every day. If things work out, the colony would be self-sufficient. But it wouldn't be a walk in the park. Stuck in a small space with the same people, eating the same food and dealing with stress, the mind would be tested constantly. People live in remote places on Earth, like scientists in Antarctica or submarine crews. These groups get mental health checks to make sure they're doing okay. But even then, they know they can go home eventually. Colonists on Mars are stuck. There's no quick way back, if ever, so only mentally strong people would pull through. Plus, there are health issues that come with low gravity. The zero-gravity experiment with the Kela twins on the ISS showed some stuff like